Let's solve these questions on electric circuits from May June 2021. Paper 1, question 8 from DBE. Okay, this is the question 8 on electric circuits. Okay, 3 resistors are connected to a battery with an unknown EMF and unknown internal resistance as shown below. Ignore the resistance of the connecting wires. Now, 8.1. In the definition of the EMF of a battery given below, A and B represent missing words or phrases. So you have the definition. Now, write down A and B in your answer book, and next to each, write the missing word or phrase. So the EMF of a battery is the maximum energy, or the maximum electrical energy, or the maximum work done. Okay, so for A, you are going to have energy or work. You can say energy or work. Okay, maximum energy or maximum work. Now, supplied by a battery per the unit charge. Okay, the unit charge passing through it, or you can say the coulomb passing through it. Okay, so B, you have the unit charge, or you can say the coulomb. Okay, remember from the definition of potential difference, which is equal to energy over charge. Okay, the formula for potential difference, energy over charge. So the EMF is the maximum potential difference, or the maximum voltage. The definition matches with the formula. Okay, in the case of EMF, you are going to have the EMF is equal to, okay, energy per coulomb, or the unit charge. You can also have work done per coulomb charge. Okay, so work done is equal to energy transferred. So sometimes you can have W instead of E. Okay, let's carry on. Now, 8.2. With switch S closed, the voltmeter reads 2.63 volts. Okay, when switch S is closed, okay, the voltmeter reads 2.63 volts. Now the question is, calculate the equivalent external resistance of the circuit. Okay, so you have a combination of a series connection in parallel with the 7 ohms resistor. Okay, so what you can do is to find the combination of the series connection first. So for the series connection, the equivalent resistance is equal to 4 plus 3. You are going to have 7 ohms. Okay, so you have 7 ohms for this branch. Now you have this in parallel with this. Now you can calculate the equivalent external resistance of the circuit. Okay, so is equal to, you have a parallel connection. Okay, a parallel connection. You can see you have a splitting node and then a joining node. Okay, back to the battery. Okay, splitting and then joining. So this is a parallel connection. So you are going to have this 1 over 7. Okay, 7 plus 1 over 7, okay, 7 and 7. You close your bracket, you raise everything to the power of -1 so that you don't have to flip. This is equal to, you are going to have 7 over 2 ohms, which is equal to 3.5 ohms. Let's move on. Now question 8.3. Let me get the question. 8.3. Okay. 8.3. Calculate 8.3.1. Calculate the internal resistance of the battery. Okay. You don't have the EMF. You don't have the internal voltage. So how can you calculate the internal resistance of the battery? You have to pay attention to what you are given. Okay. First, you have to note switch S is not the main switch. Okay. You can have switch S opened, the current is still going to flow in the circuit. Okay. Even if switch S is opened, the current is still going to flow in the circuit. So you understand, switch S is not the main switch. We can solve this question simultaneously. You have to pay attention to what you are given. From the previous slide, when you read the question, you are told, okay, you are told when switch S is closed, the voltmeter reads 2.63 volt. This is what? This is the external voltage, the voltage which is supplied to the external circuit. Okay, the output. So you have, let me show you. You have this combination when switch S is closed. Okay, so we can use this formula to find the internal resistance. Okay, we can set two equations so that we can solve for the internal resistance. Okay, let me show you. So you have the external voltage plus the internal voltage. You need the current and you need the external resistance. You can find the external resistance. From the previous question, we found the external resistance was 3.5. Okay, 7 over 2, which is equal to 3.5 ohms. We need the current. Okay, we need the current. We are going to solve this question simultaneously. So let's find the current first using this information. Okay, we know the external voltage is equal to the current times the external resistance. Okay, so the external resistance from the previous question is equal to 7 over 2, which is equal to 3.5 from the previous question. Okay, question 8.2. So we have this when the switch is closed. Okay, when switch S is closed, so we can find the current. The current is equal to external voltage over external resistance, which is 3.5 from the previous question. Okay, so the current is equal to, you have 2.63 over 3.5, which is equal to 0.0 0.75 amperes. Okay, so this is the current when switch S is closed. You have this current from the battery. Okay, from the battery, and then it's going to split and then join back to the battery. Okay, so you have 0.75 from the battery when switch S is closed. Okay, so you have the EMF is equal to the current is 0.75 times the external resistance 3.5, okay, plus the current 0.75 times the internal resistance which we are looking for. Now the EMF is equal to 0.75 times 3.5. You are going to have 2.63, okay, external voltage plus 0.75 times lowercase r. So this is the first equation. Okay, let's create the second equation with what we are given. You are told when switch S is opened, okay, when switch S is opened, okay, you have the voltmeter reading is 2.8. Okay, so when switch S is opened, now this branch is useless. Okay, when switch S is opened, this branch is useless. Now you have only 4 ohms and 3 ohms connected to the battery. Okay, so 2.8 volts is the external voltage in this situation. Okay, in this situation, you have a new external voltage and you are going to have a new current. Okay, in this situation. So you're still going to use the same formula for the EMF. You need the new current in this situation. You have your external voltage. You can find the new current in this situation. Okay, to find the current, you are going to divide by uppercase R on both sides. When you divide by uppercase R on this side, you are going to have the current. You also divide by uppercase R on this side, you are going to have this. Okay, so this is equal to external voltage is 2.8 over now the external resistance. You only have 4 and 3 ohms in series. So 4 plus 3, 7. Okay, 7 ohms. This is equal to 0.4 amperes. Okay, remember this is useless. When switch S is open, this is useless. You only have 4 and 3 in series. So 4 plus 3, 7. Okay, now you have the new current, which is 0.4 in this situation. Okay, in this situation. Now, you are going to have the EMF is equal to 0.4 times 7. Okay, 7. The external resistance plus current times internal resistance. The EMF is equal to, this is 2.8. Okay, 2.8 plus 0.4 times lowercase r. So this is your second equation. So equate the two equations because they are both equal to the EMF. Okay, so you have this part is equal to this part. Okay, now you have 0.75 times lowercase r. You bring this to the left, you have minus 0.4 times lowercase r equal to 2.8. You bring this to the right, you have minus 2.63. Okay, you are going to have 0.35 times lowercase r, which is equal to, you are going to have 0.17. To find r, you have to divide by 0.35 on both sides. So the lowercase r is equal to 0.17 over 0.35, which is equal to 0.49 ohms. Okay, now question 8.3.2. Calculate the EMF of the battery. You can use equation 1 or equation 2 to find the EMF of the battery because you have the internal resistance. So you can use equation 1 or equation 2 to calculate the EMF. Okay, let me use equation 1. So you have the EMF is equal to 2.63 plus 0.75 times the internal resistance. The EMF is equal to 3 volts. Okay, or you can use the second equation. The EMF is equal to this 2.8 plus 0.4 times lowercase r, okay, which is 0.49. So the EMF is equal to 3 volts again.